Okay, so for today, though, we are looking at doing different operations with radicals, and the complex numbers just means it has an I in it, okay? So I'm kind of putting the i's, the radicals, and we're going to be like adding, subtracting, and multiplying with them. Yay! It's not terrible. It's not terrible. It just kind of reinforces some of the stuff we already know how to do. All right, so first thing we're going to look at is adding and subtracting. Now, what do we know about things that are adding and subtracting? Can they be alike? They have to be alike, right? Have to be exactly the same. And I know we talked a little bit about this. If we're adding like terms with radicals, the radical has to be exactly the same. So a radical 2 has to go with a radical 2, right? A radical 3 and a radical 3, great. A radical 3 and a radical 2, no good. They got to be exactly the same. All right, so combine your like radicals. So if I had 3 radical 5 and 7 radical 5, if I added those, what would you tell me it is? It'd be 10 radical 5. Yep, the radicals, the matching ones, they're just like the matching game. You're putting them together. So those don't actually add. Unlike radicals, if I had 4 radical 3 and negative 5 radical 2, radicals are different. I would just stay like as is. I can't do anything with that. Okay, but you may need to simplify your radicals first. So if you have a radical 24, there's pairs hiding in that. So those factor trees that we keep asking, when do I do factor trees? All the time. You always try to do a factor tree. Okay, so number 1, radical 3 minus 5 radical 3. Are the radicals the same? Now, what number's in front of this one? There's a 1 there. Good. So I know the radical 3 is the same, so I have that. And then just do the numbers in front. It'd be negative 4. Right? 1 minus 5 gives me negative 4. And the radical 3 just kind of follows me along. That's that like term that stays together. All right, number 2, 4 radical 7 plus 2 radical 28. Are those radicals the same? Yeah, they're not the same the way they sit, but I can simplify that one. Okay, that's going to be 7 and 4, 2 and 2. Good. So I have a pair of 2's, right? So 2 and the 2 that's already there. It's going to be 4 radical 7. Just bring down this other part. Right, I just brought that down with me. Now can I put them together? Yes, now I can. So again, the radicals are the same, so that's going to stay. And then 4 plus 4 is 8. So, terrible? No, it's kind of taking some skills we already know how to do. So then number 3, it's okay. Do the radicals match right now? So what should I do with them? Simplify them. We'll do our factor trees. So 2 and 16, or however you decided to break that down. All right, so we have 2 pairs of 2's, which is 4, times the 5 in front, is 20. Radical 2. All right, and then this part, not moving on. I was ready to go to the next one. Okay, that's 9 and 2. 3 and 3. So pair of 3's times the negative 4 that's already there. It's negative 12. And I have a radical 2. Now, am I guaranteed every time I do this that they will match and I can put them together? No, not always. But does this time do they? Yeah, they actually do. They're both radical 2's. So I know then my answer is going to have a matching radical 2 on it. And 20 minus 12 is 8. Good. Not too bad. Leave it. Yep. Leave them simplified, but yeah, nothing else then. Right. So factor trees, do they happen a lot? Yeah, a whole lot. You guys want to try number 4 on your own? Yeah, try number 4. All right, guys. So first thing, the way they sit, they're not the same. So we'll have to simplify. We can't actually put them together. So we'll do our factor trees. So on the first one, I do have a pair of 2's times the -4 out in front, so -8, and then 2 and 3 would give me the 6. Okay, on this one, we'll do our factor tree of 4 and 2. So we get a pair of 2's times the 7 out in front, and then I have radical 2. And some of you got to that point and you're like, what did I do wrong? Because they don't match. And they don't match. So do I put anything together? No. If they're not the same radical, they're not like terms, and I'm done. I don't have to worry about that anymore. Do you see what you did? Oh. So you're like, yeah, they work.
I got 6 radical 2.
Gotcha. Christian? Hey, guys. Mm-hmm. Yes, if one of them has an I and one of them doesn't, are they like terms or not? They would not be. So to answer his question, let's say you had 5i radical 3 plus 7 radical 3. The radicals match, but can you add a 5i and a 7? No, so you wouldn't be able to do anything with that. Right. And now if that was 5i and that was 7i, then yes, you could. Great question. Okay, let's shift gears just a little bit. We were adding and subtracting. Now let's look at multiplying. When you multiply, do they have to be like terms? No, they don't have to be. So right away when I look at this, what's your first instinct? It's distribute. Radical 10 times radical 6 is radical 60. Radical 10 times 3 is 3 radical 10. Right? That looks like a 6. One's inner radical, one's not, so they don't actually multiply together. They just kind of, one's out in front, one's inside. So can I add those together? Do the radicals match? One's a 60, one's a 10. They don't match, but do either of them simplify? Yeah, I can simplify though. So I'm going to distribute, and then it's really right back to what we just worked on. Okay, now I'm going to simplify. So that's 6 and 10, 2 and 3, 2 and 5. So I do have a pair of 2's. Radical 15. Can I do factor tree on the 10 gives me 2 and 5, so I can't do anything. So I have 3 radical 10. Can I add those together? No. So then I would be done. So we want to distribute first, okay? And then after that, it's just like the problems we just looked at. Simplify your radicals by doing your factor trees, and then try to put like terms together. Sometimes they have like terms, sometimes they don't. It just depends on the problem. All right, so number 5. What do we do first? We distribute. So radical 2 times radical 6 is radical 12 plus radical 2 times 5 is 5 radical 2. Honestly, guys, part of the issue students have is they go too fast on the multiplying part, and then they lose signs or they lose numbers or whatever. So just really slow yourself down, especially when we look at the next one. We get a lot more going on. Yeah. All right, well, let's deal with 5 before we get into that one. All right, so from here, do the radicals match? No, but can I simplify? Yes. So, sorry, my brain was already going 4 and 3. 2 and 2. Good. Pair of 2's. Radical 3. Does this radical simplify? No. So 5 radical 2. Do they match? No. So if they don't match, you don't do anything. I'm done. We always simplify though, right? Always do those factor trees. Only if it's a division problem. Makes sense, right? No, it's a great question though. Yeah, only if it's an actual division problem can you do that. All right, now number 6. Now, you're going to learn real fast with me. There is a 4-letter F word in math class that I consider a curse word. What'd you just say? Can you believe she spoke to me like that? Did you hear the word that came out of her mouth? She said foil. In your lab, it's okay because it's, culinary. But when you say foil in math class, and I know a lot of you probably learned it that way, it drives me insane. You distribute. Because if it's 2 terms times 2 terms, sure, FOIL works great. What if it's 2 terms times 3 terms? FOIL doesn't work anymore. And then people don't know what to do. That's why I hate the word FOIL. You just distribute, right? You take the first one, and it gets distributed to both parts in the second one. I'm sorry. And you multiply. So what's radical 5 times radical 15? Radical 75. And then radical 5 times a negative radical 3, negative radical 15. Okay, and we'll go nice and slow. So I just took the first term and I distributed it to the other parenthesis. Now what do I do next? The second term, I'm going to distribute that one, right? So 2 radical 3 times radical 15. 2 radical 45, right? Outside numbers, inside numbers. You got to really be careful because there's a lot of parts and pieces going on here. And then 2 radical 3 times negative radical 3. All right, I'll go one step at a time. But it'd be negative 2 radical 9. We'll just go one step at a time. Do I have like radicals right now? No. So my next step should be to simplify them. All right, so if I simplify, radical 75. It's 25 and 3. So 5 radical 3. Simplifying. Radical 15. If I do a factor tree, it's just 5 and 3, so no pairs. So that's going to stay minus radical 15. Radical 45. So 9 and 5. 3 and 3. Good. So you're going to have, now be careful. I have a pair of 3s, but there's a 2 out in front. 6, and then radical 5. And then radical 9, which is, that's just 3, not the square root of 3, right? Just 3 times that will give me negative 6. What's the square root of 9? 3 times the 2 out in front. Yep. Right, because I simplified and look at all your radicals. They're all different. So I'm done. I can't do anything else with this. Not always. Sometimes there's stuff that's the same. You never know until you simplify everything. There's a lot of pieces to it. I know, a lot of pieces. Mm-hmm. I did. I hate the term foil. Yeah. I don't say foil. I distributed. Oh no, you have to. Mathematically, yes, but I hate the term foil. Oh, drives me crazy. Now in culinary, I use aluminum foil all the time. Okay, so number 7. Are you ready? We got to distribute. So how slow should we go? Slow. Maybe not a snail, but But turtles, they're a little faster. All right, so nice and slow. Radical 6 times 4 radical 3. 4 radical 18. Right? Outside numbers, inside numbers. And then radical 6 times negative 3 radical 6. Negative 3 radical 36. And some of you are like, wait, that's perfect. I'm like, great, let's just one step at a time. Okay. I know some of you see it and you're like, want to do something with it. Just hang tight a minute. All right, and then we just take the second number, we'll distribute that one. So negative 2 radical 3, negative 8 radical 9. Don't say it starting again. So we distributed the first part, now we have to distribute the second. So negative 2 radical 3 times negative 3 radical 6. 6 radical 18. Can you put anything together right now? Am I okay to do that before I simplify? Why would you want to simplify them both? I mean, I'd rather simplify them later. Why are to put them together? All right. But yeah, guys, right away at this step, I can put those together right now. Good. It'd be 10. See that plus sign? Yeah, 10 radical 18 minus 3 radical 36 minus 8 radical 9. All right. So I did put my like stuff together, but can I simplify my final answer still? Yeah, I still need to finish simplifying. Yep. Those darn factor trees, they come back constantly, don't they? So 6 and 3, 3 and 2. So we have a pair of 3's times the 10 out in front, 30, radical 2. Okay. Next one, square root of 36 is 6 times the negative 3, negative 18. Square root of 9 times the negative 8. Wait a minute, do you have like terms again? Yeah, you got two just plain old numbers sitting there. Good. So I have 30 radical 2. Like terms in my plain numbers, that's just negative 42. And we're done. So yeah, so guys, in math, you're going to notice a lot how this semester progresses. You may think you've simplified everything, then you do something else, you're like, ah, crap, I can simplify again. Like, you got to constantly be looking for, can I simplify further? Okay? Doing all right? We're almost to a brain break, I promise. Is that what you wanted? Yes. Now, every year, people mess up on that number 8, that style of problem, all semester long, no matter what we're doing, more than anything else. What's it mean to square something? Say that again. You multiply it by itself. People don't always want to do that. Multiply by itself means I really have radical 11 minus 2 times radical 11 minus 2. Squaring something means you multiply it by itself. So you're going to want to write that down twice. And then now I can actually distribute. I can multiply those together. Yeah, for whatever reason, people freak out when you see a problem like that. They don't know what to do with it. So what is radical 11 times radical 11? Radical 121. Radical 11 times negative 2. All right, so we distributed the first part to both. Now we distribute the second one. Negative 2 times radical 11. Negative 2 radical 11. And then negative 2 times negative 2 is positive 4. Any like terms right away? Yep, sure do. Right here in the middle, I can put those together. They cancel. I disagree. Negative 2 minus 2, negative 4 radical 11. There's a plus 4 there. Good? Done? Square root of 121, that's 11. Yep, so that just became 11. And now there's like terms again. Those like terms constantly sneaking up on you. So that's 15 minus 4 radical 11. Now am I done? Yes. Finally I'm done. Those two are no longer like terms. All right, so how are we feeling so far? Not bad? Good. Doing all right. Yes. Okay, so let's look back now at adding and subtracting. So we went adding and subtracting with radicals. We did multiplying with radicals. Now we are adding and subtracting with i's, right? See how we've kind of shifted there a little bit? The same thing, when you have an I, it has to be a like term, right? They have to be alike. Now, when I'm looking at this very first problem, you see how it's like negative 5 plus 8i plus, and then you have another parenthesis stuff. Are the parentheses necessary? No. Now, every year people see this and they're like, oh, I distribute because there's parentheses. But no, the symbol inside says add. So these parentheses, if I'm adding, the parentheses are not necessary. Not necessary. Okay? So do you have like terms in this one? Yeah, negative 5 plus 6. That was the hard question of the day. And then 8i minus 4i is a positive 4i. Ta-da! The hardest thing about these problems is people just wanting to multiply because they see parentheses, but they're not necessary. All right, so again, plus signs. Do the parentheses matter? No, I don't really need these parentheses when it's a plus in between. All right, so like terms, 7 minus 3. I'm always worried when I give a basic math and no one says a word. All right, negative 2i plus I. Be negative 1i, or negative I. Now we're done. Isn't adding hard? You want a page of adding, right? What about if there's a subtraction sign in between? And she's like, I like the, no, you don't just type it in your calculator. Okay, this is like a negative 1 here. You have to distribute this. Now, does this first one change? No, because remember, we read from left to right. So if I'm looking across, there's nothing in front of this one. So negative 10 minus 3i. But this negative gets distributed here. So that'd be negative 4 plus 9i. Now, if you're somebody who's like, how am I ever going to remember this? Like there's rules for plus, rules for minus, whatever. Could you have looked back up at this problem and treated it the same way? Well, that erased all kinds of things. Right? Could I have looked at this and been like, oh, look, there's a plus 1 there. I should distribute that? Could you have? Does it change anything? No, that's why it didn't matter. But if I distribute a negative, does it change things? Yes, it does. You can. You can. But you know what's going to happen? People are going to forget to do that. But if you're comfortable with that, by all means. Because that's how I do it. I do them in my head that way. But I've found through the years that students don't do that. They forget. So then I have negative 10 minus 4. It's negative 14. And negative 3i plus 9i, positive 6i. Yeah, that's it. Adding and subtracting not bad as long as you remember that negative in between there. And don't multiply the whole thing together. Don't use the F word on it. Watch your mouth. Man. Kiss your mom with that mouth? Jeez. All right, so just a couple more, just get a little practice here. So on this one, do I have to worry about parentheses? Yes. You see the negative? Yeah. So negative 5 minus 3i. Distribute here. So you're going to have two negatives make positive 2. And negative 1 times 4i, negative 4i. So then you can put like terms. Negative 5 plus 2. Negative 3i minus 4i. Negative 7i. Parentheses matter in this one? No, you don't really need to worry about parentheses here because it's a plus sign. I'm going to tell you right now, there will be at least, I'm going to say at least 5 of you who will do this wrong on your test Thursday. Prove me wrong. That doesn't mean more of you. Less of you than 5, okay? So plus sign, you can distribute a positive 1 if you want, but it doesn't really matter. So negative 3 plus 3, that cancels. 9i plus 9i. 18i. And I'm done. people distribute, they try to foil that. I know, I'm sorry. Because they don't see the plus sign. And that's how I grade. I'm like, wrong, max points off, and then I'm like, see that sign right there? Stop multiplying. It means add. Don't be one of them. All right, are we okay? Can I bypass this? It's more of the same. It's just more of the same. It's bypass. Why are you turning in a blank sheet of paper? All my answers are imaginary numbers. Yeah, no, don't do that. It's not funny. Okay, now if you go back to the day that we watched that really boring video on what I was in imaginary numbers, I know it's boring, but it gives you good info. But remember we talked about I squared was equal to -1. It was in our notes. We talked about that, right? Yeah. Okay. So just like math's got those weird rules, right? You can't leave a radical in the bottom, so you have to rationalize. You cannot leave an I squared as part of your answer. You have to simplify. Okay, so take a look. Now this one, see there's no plus sign in between this? We actually distribute these. So -2i times 5, -10i, and then -2i times I, -2i squared. Now hang that, hold on. Make sure we're clear on what's going on here. So I distributed, right? I and I makes I squared. Now, we are told I squared is -1. We talked about that last week. So wherever I see an I squared, what can I put in place of that? -1. This is -2 times I squared, correct? So what's -2 times -1? +2. Oops, there's an I on that. +2. So in other words, if there's an I squared attached to something, what's it doing to it? Multiply by -1, which is doing what to its sign? Switching its sign. So will you still have an I or an I squared attached to it? No, not to that part. I squared is being replaced by -1. I squared is no more. So 7i times 3i, 21i squared, but I squared is equal to -1, which is -21. And if you're cool to go from 21i squared and just write, oh, that's -21, I'm cool with that. Donnie. It equals the square root of -1. Yeah. Yeah, I is the square root of -1. I squared is just -1 without the radical on it. All right, so let's get a couple under our belt here because we're about out of time. So -3 times 4. -3 times -2i. +6i. Be very careful. If you lose one negative sign, you're in trouble. Whole thing's wrong. All right, distribute here. 6i times 4. And then 6i times -2i. 12i squared. All right, so step 1 is I just distributed the whole thing. Notice there was no plus sign or minus sign in between my parentheses, so I just distributed. And then I have some like terms in the middle, yes? Okay, so that's going to give me -12, bringing that along with me. 6i plus 24i, 30i. And what's going to happen to that? Just a +12, right? This entire I squared gets replaced with a -1, which just makes that a +12. See like terms again? In this case, they cancel, so it's just 30i. We all right? We doing okay? All right. Let's look at this. Let's skip this one for now because we're out of time. Sorry. If you worked ahead. Sorry. All right. On this one, what do you notice about these two parts? They're the same but opposite, right? Like the numbers 5 and 3i, 5 and 3i, one's a plus, one's a minus. Let's find out. 5 times 5. 5 times -3i. 3i times 5. positive 15i. And then 3i times negative 3i, negative 9i squared. So what happens to the i's in the middle? Those cancel. So I have 25 minus 9i squared. But what happens to that? It changes to a positive, right? Because this entire piece becomes negative 1. So that's 25 plus 9, which is 34. It can ring because I'm almost out of time with you guys. I'll answer it later. All right. Are we okay on that right there? Okay. So the last thing we need to talk about real quick is a vocab term. It's called a complex conjugate. Complex just means it has an I in it. That's all that means. Conjugate is what we just looked at, where the two parts are the same, but the sign in between is the opposite sign. Okay? So I'm going to ask you, as we go through things, to tell me what the conjugate is. So if I look at this, see how they're conjugates? The first ones are both negative 2. The second parts are both 7i. And the only thing that was different is the sign in between. Okay? So what happens when you multiply them together? What happens to your answer? You get what type of number? Just a whole number. Yeah, you end up with no i's at all anymore. Okay, for sake of time, I'm not going to multiply that one together. But give me the complex conjugate, and then for homework, you'd have to multiply. But can you at least tell me what the complex conjugate would be? Good. Not sure what just happened there. Okay, so it'd be 4 plus 6i. And then you'd multiply. What type of answer would you get? A whole number. What about here? It would be negative 8 minus I. Yeah, guys, whatever that first number is, whether it's positive or negative, it stays the same. Okay? The only sign that changes is in between. We ran out of some time today. Are we okay? Questions?